Hi there students, this is Dr. John, your physics and math professor. Today we're coming with another optics video. This time we're going to explore thin lenses, both concave and convex lenses. I've drawn two of them up here for you. Let me just give you the names so that you remember them. Previously we did a video on mirrors. I've redrawn a couple of mirrors really quickly here. Remember here we had a concave mirror. The idea is when the light over here, this green arrow which represents light or a standing person, comes this way and hits the lens, or hits the mirror in this case, it gets reflected this way, but notice how it seems to come into a cave. There's sort of a cave here, cave shape. So that is called a concave mirror. This one, the light can't get into the cave, so it's convex, it's vexed. Similarly over here, notice here, this light over here, we usually have the light coming from the left side. We can switch that around, have it coming from the right side, just reverse everything that we're doing then. So if this is over here, this is a object drawn here with an arrow. This would be the head of a person, the feet going down here. We have the arrow so we know which way is up, which way is down. Light's coming this way and hits this lens. Now notice here, this is like the opposite of a cave. It can't get into the cave. So this is a convex lens. Actually, this is sort of like a double convex lens. This would be a single convex lens like this, and then it would be flat on one side and convex when the light comes in here. But what we've actually done is added another convex lens on the other side. Usually we just call it a convex thin lens, but sometimes people will call it a double convex thin lens. So just be prepared for either one. Now take a look at this one over here. When the light comes here and hits here, notice it seems to hit a cave. Hence this is called a concave lens or a double concave lens. These lenses might be made of glass or plastic or some other material that refracts light or slows light down in practical terms. So I'm going to illustrate what light does over here by expanding. I'm taking this convex lens and blowing it up. Remember, we're talking about thin lenses. These things are really thin. What we really mean by thin lenses is that the height of the object is very small compared to the distance here. So this should really be very small. I've made it a little bit bigger. And the lens is quite thin. It's not big and fat like this one over here. I've redrawn this here very fat. Sometimes they'll draw the lenses like this or like this. These are easy for you to notice, but sometimes they'll use shorthand. Sometimes they'll do this. They'll put a little arrow on this and a little arrow on this and say that this is the lens. Well, in other words, just think of it this way. Think, what if you continued with the arrows? You would get a lens. So that's easy to visualize. And a concave one, they would do with the opposite kind of thing. This is a little bit harder to visualize, but just think of it being fat on the outside and getting thinner on the inside. So it's sort of fat over here. I'll just erase this so I can show you. So it's sort of fat over here and then it gets thinner, see? Like that. So what they do is they'll represent it like this. Here's a line, and instead of this arrow, they'll use the other arrow. Fat on the outside, and then getting thinner like this, just like this. So this would be a symbol that sometimes you would use for a convex lens or a concave lens. Hopefully, if they use those symbols, they also tell you what the symbols mean so that it's not confusing. So let's take a look at this here and see what light would do if it hits this convex lens. I'm going to draw a beam of light right here for you, and then we're going to try to illustrate that. So here I've drawn a beam of light. I've made a thick ray of light so that you can see it. Really, it would be a bunch of individual little lights or photon particles or whatever you want to call it. But let's imagine it as being a ray of light like this that's thick. It's easier to see what it might do. So notice here, if I continue this on until I hit the lens here. So now the bottom of this has hit the lens, but the top has not hit the lens yet. So just like if you were, say you're running through air and then suddenly you're trying to swim through water. Water is harder to swim through. You go much slower when you go through water. So in this way, when light is going through air and then it hits a lens, which is made of plastic or made of glass, it slows down. So just think of the bottom here would start slowing down. So you would go a little distance here. In the meanwhile, this here on the top will have gone a longer distance because this will have slowed down here. So now as it enters the lens, this will have gone a short distance and this will have gone further. So can you see how, because this distance over here is going through air and now it starts going through the glass, this distance it's going to cover quickly. And so what you're going to do is you're going to sort of bend the light. So now you're going to be bending the light like this until you hit the going out. And this is where the double convex lens comes in. You're going to have the same effect on either side. Notice when the top here comes out, it's going to start going faster while the bottom is still going really slowly. So this here is going to be going a distance here, and this will have gone this distance, whereas this will have gone a further distance. So that by the time you're out, your light will bend inside the lens, it'll bend again when coming out. So notice the light here will bend inward, and if you had a ray of light here, something similar like this, it would also bend inward. So can you see how a lens like this, a convex lens, would tend to converge things? So a ray of light that hit here would tend to come down. A ray of light that hit here would tend to come up, and would tend to be a converging lens. Let me write that down for you. So I'm going to go back to this thing over here and draw what would happen with the light from here. Now normally what we will do is we'll try to take two lines going from the tip and seeing where they connect. And where they connect would be where an image would form. I'm going to use various colors for that. So one ray of light would come here, straight this way. We call these ray diagrams because we draw rays of light. It would come and hit the lens right here. Normally we'll draw something parallel to the principal axis. The principal axis. Abbreviated as PA, or it's the principal, it's the main axis. So we're going to go here, and remember we said it would bend the light inward. Now, in what way will it bend the light? It will bend the light to this thing called the focal length. Notice I've written down the center of curvature, which would be like the center of curvature of this side with this. This would be the center of curvature of this side. And in a similar way to a mirror, the light will focus on the focal length, which is a halfway between the center of the lens and the center of curvature. Here we have a center of curvature on two sides. Sometimes some books will label this center of curvature not as C, but as 2F. Just not to confuse you, just to realize you can have either labels there. I'm just going to erase this one here because we're going to have other things going on the side here. So the light will come down and it will hit this focal point. Let me just draw that in here. I drew that in here. It bent here in the lens, comes down this way, and hits this focal point and continues on there. Now normally we'll try to draw two lines. So what other line will we draw? Previously we tried to have something to do here with the mirror. We tried to go through the center. That doesn't quite work here. So what instead we try to do is we try to go through the center of the lens. If you think about it really carefully, right at the center of the lens, the lines up and down will be basically flat, especially in a thin lens. So it's not going to deflect any. So we'll take another line and go straight through the center of the lens and see where that line, this line here, intersects with that line. All right, so here I have the brown line, which goes right through the center where it doesn't deflect at all, and it keeps going. And notice these two hit right here. So I'm going to create an image here. The image is upside down. It's the same arrow, it's just upside down. Now this is called a real image. Now why is it called a real image? Because if you have lenses, the light should form or should go to the other side and form an image there. If it goes to the other side where light should go, it will form a real image. So this is called a real image, and that real image is often labeled as with an I. So this is O and this is I, and that's where they intersect. Now notice this is very similar to this kind of a mirror here. It's a converging mirror. This one happens to be concave. It's a converging mirror. The converging lens is convex. Don't let that confuse you. Just realize what light does. Here it's actually going through the lens. Here it's being reflected by the lens. But there's a symmetry about this converging lens here and the converging mirror over here. This one creates a real image, but it does it on that side. It does it on the side where a mirror should reflect. This creates a real image on the side where an image should occur. For a lens, it should occur on this side. So let's now look at this thing and see what happens to light when it hits a concave lens. Actually, this is a double concave lens. It's concave this way with this center of curvature and concave this way with this center of curvature. I'll just redraw this thing over here and illustrate this for you again. So here I've redrawn this concave, looks like a cave when the light comes in, which is this one over here, this concave lens to see what light's going to do when it hits here. Here I have this blue ray of light that's coming in. Now notice it's going to hit on the top first, but it hasn't hit in the bottom yet, which means it's not going to move very far here before this has moved here, which means by the time it's in here, it will have twisted this. This will have gone further, so it sort of twisted the light a little bit, and it's gone that way. So now it's going to start going this way, and over here, if I draw it exaggerated a little bit, notice it's going to hit here, it's going to hit the outside first. So when it starts going on the outside, it's going to go faster than it would on the inside. So this distance it covers here, it'll cover this distance over here. So that by the time it's out, it will have gone like that. So the light will have bent twice, once on the income, once on the outgo, and it'll end up like this. So notice what light does when it hits this concave lens over here, double concave. I've exaggerated over here. It comes in here, parallel to the primary axis, and then it would go somewhere over here. Now, what we did before with mirrors is that when it goes over, and in mirrors, of course, it reflects that way. When it goes over, the back line hits the focal point. So I'm going to draw that in here, just like we did with mirrors. So here's the line here that would go up. It would, just like I drew over here, it would go up diverging. So this would be a diverging lens. I'm going to write that over here, just like that, a diverging lens. And if I go back here, this thing come back, which makes it looks like light is coming from the focal point. It's not actually coming from the focal point. Here in this case, light actually goes to the focal point. Here it looks like it's coming from the focal point and it goes away. Now remember, we drew two lines here before. One of them we drew through the center of the lens. So let's do the same thing here with this fun brown color. Here's my light line that goes right through there. So it goes right through the center. Notice these two things seem to intersect right there. There's the image, just like this is an image. Notice this image is upright. This image is upside down. Now this here is called a virtual image. Why is that? Because lenses should create an image on this side of the lens. They should not create an image on that side. Just like mirrors over here should create images on the reflected side. So this is a real image. They should not create them on this side. So this is a virtual image. In the same way, in a parallel way, lenses should not create images over there. So this would be a virtual image. Just like that, excuse my messy writing down there. So I hope that helps with a very brief introduction into lenses. And we're going to continue on with other videos. Remember to like and subscribe. And also check out my website where I'm going to have cool sheets that are going to show all the diverging lenses and mirrors and the converging lenses and mirrors. I'm going to do them all on one sheet just like this so that you can download that. It's all for free. There's no cost or obligation. You don't need to register. So I'll see you in the next video. Bye-bye.